So here we have the 2018, this is question 4, Leaving Cert Ordinary level, and this is a question on sequences and series. So it says the first 3 stages in a pattern of grey and white tiles are shown in the diagram below. So I'm just after drawing out the first 3 stages. So we can see, and we're asked to draw the 4th stage. So we can see that in the first stage we have 1, 2, 3 kind of all together on the bottom, and the last one is white. Then we have 1, 2, 3, 4 on the bottom, the last one is white. 1, 2, 3, 4, 5 on the bottom, and the last one is white. And then going up, the top bit on this of the grey bit is 1, 2, and then it's 1, 2, 3, and we're adding another column, and then it's 1, 2, 3, 4. So I've drawn out stage 4. So in the stage before it was 1, 2, 3, 4, 5 on the bottom. So there'll be 1, 2, 3, 4, 5, 6 on the bottom. And then the last one is white. And then there was 1, 2, 3, 4 columns here. So there'll be an extra 1, 2, 3, 4, 5 columns. So going up, it's 1, 2, 3, 4. So it'll be 1, 2, 3, 4, 5. And there'll be an extra white one at the top here. So then we're asked to, based on the pattern, we're asked to fill in this table. So we're going to look at the stage number and the number of grey tiles, number of white tiles, and the total. So in the first, we have 1, 2, 3, 4 grey tiles. And then we have 2 white tiles. So the total is going to be 6. So we have 1, 2, 3 on this side, so 1, 2, 3 on that side. So we can multiply 3 by 3 and we'll get 9. So we have 9 grey tiles, and we're always going to have 2 white tiles. So we have 11. So now we have 1, 2, 3, 4, 1, 2, 3, 4. So 4 by 4 is 16. And we have 2 white tiles, so we get 18. In this case, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 5 by 5 is 25. So 5 by 5 is 25. And then we have 2 white tiles. And then, so it'll be 27. So they asked us to fill in stage 5, even though we haven't drawn out stage 5. But we got that in the number of grey tiles in the next one will be, there'll be a length of 1, 2, 3, 4, 5, 6, and it'll be 6 up as well. So it'll be 6 by 6, which will be 36, and then plus 2, so it gives us 37. So that's that one. And then we're told, assuming the pattern continues, the number of tiles in stage n, so the general term, is given by n squared plus bn plus c. So our b and c is an element of n. So in stage 1, so the number of tiles, so the total number of tiles, so we're dealing with the total number of tiles. So I'm going to go with the total number of tiles in stage 1, and that's 6. I'm going to write, so I might just do a pattern. So we have 6 with the total number, 6, 11, 18, 27. So 6, 11, 18, 27, 37. So if this is a quadratic sequence, I'm just going to check first myself. We should have a constant second difference. So to get from here to here, it's a jump of 5. So to get from 11 to 18, it's 7. Here is a jump of so it's a jump of 36. Sorry, that should be 38 there, because 36 plus 2 is 38. So here's a jump of 9, and this is a jump of 11. So 2, 2, 2. So we have a constant second difference of 2. And when we have a quadratic in the form an squared plus bn plus c, this a here, twice that a, is equal to the second difference, and our second difference is 2. So 2a is going to be equal to 2, so a is equal to 1, and they've just left it as n squared plus bn plus c, so we didn't actually have to work that out anyway. But we have to work out the values of b and c. So what I'm going to do, so I'm going to take stage 1, maybe stage 1 I have 6, In stage 2, I have 11 because stage 1, 6 to 11. And I'm going to sub in n equals 2, let it equal to 11, n equals 1, let it equal to 6, and get two simultaneous equations. So when I'm subbing in n equals 1, I get 1 squared plus b by 1 plus c, and that's equal to 6. So that would be 1 plus b plus c is equal to 6. So b plus c is equal to 6 take 1, so it's 5. So that's my first equation. And now I'm going to sub in n equals 2. So 2 squared plus 2b plus c is equal to 11. So 4 plus 2b plus c is equal to 11. So 2b plus c is equal to 11. Take 4. So that's going to be equal to 7. So now I have equation 1 and equation 2, and I'm going to solve them using simultaneous equations. So equation 1 was b plus c is equal to 5. So I'm just getting them from here and here. And equation 2 is 2b plus c is equal to 7. So I think I'm going to cancel out my c's. So in order for one of my variables to cancel, I have to have the same coefficients. So they both are 1c, and then they have to have opposite signs. So I'm going to multiply both sides of this line by minus 1 to get an opposite sign on this. That'll be minus b and minus c is equal to minus 5, and then 2b plus c is equal to 7. So these cancel, and then 2b take b is just going to be equal to b, and then 7 take 5, so that's going to be equal to 2. So b is equal to 2, and I'm going to take one of my original equations. So I got b plus c is equal to 5, and if b is 2, so 2 plus c is equal to 5. So c is equal to 5, take 2, so c is equal to 3. So b is equal to 2, c is equal to 3. So my equation is n squared plus 2n plus 3. So that's my general term. And then I'm asked to find the number of the stage which has 443 tiles in total. So n that I plug into this equation is the stage number. And what I let that equal to is the total number of tiles in that stage. So I'm going to let this equal to 443. So then I'm going to form a quadratic. So bring over my 443. So minus 443 is equal to 0. So n squared plus 2n minus 440 is equal to 0. So now I have a quadratic. So what I might do, I can use the minus b formula, or what I might do is divide 440 by a few different things to see if I can get anything that comes near that they'll have a difference of 2. So say if I divide by 40, it won't work. So 20, no, 440 divided by 15, 16, so 25. I might just use the minus b formula because it'll be hard to get the factors. Just give it another try if I can. So I'm just dividing by different numbers, 440. So what I might do is do out my factors. So if I divide it by 2, 440 divided by 2, I get 220. If I divide that by 2, I get 110. Divide that by 2, I get 55. Divide that by 2, so it doesn't go in. So 55 divided by 5, I get 11. So 440 divided by 11 won't work. So divided by 20. So actually, if I divide 440 divided by 22, I get 20. So I could have, so they're factors of minus 440. So I could have plus 22 multiplied by minus 20, and I got that just by doing out the factors. So that would be n plus, and they'd add to give plus 2, 22, and then n minus 20 is equal to 0. So now I have to let each of them equal 0. So n plus 22 is equal to 0, n minus 20 is equal to 0, n is equal to minus 22, and n is equal to 20. But I'm not going to have a minus stage of my pattern, so I'm going to have to reject this answer. And I'm going to have to say that it's going to be stage number 20 that has 443 tiles in total. So that is my answer for that question.